Hey guys, so I'm trying out this problem, populating next right pointers in each node. Okay, let's have a read. We're given a perfect binary tree where all leaves are on the same level and every parent has two children. The binary tree has the following definition. Find it has a left, it has a right, it has a next. What is next? Populate each next pointer to point to its next right node. If there is no next right node, the next pointer should be set to null. Initially, all next pointers are set to null. Okay, let's understand. Um, okay, 2's one's right is null, 2's right is 3, 4's right is 5, 5's right is 6, 6's right is 7. Okay, that is how we have to set it up. Root is this, output is, okay, solution, we have to return a node, connect node root. So we return basically the root of the tree, I guess. Given the above binary tree, your function should populate each next pointer to point to its next right node, just like in figure B. The CLI output is in level order travel as connected with the next pointers, with hash signifying the end of each level. Okay, empty is empty. You may only use constant extra space. Recursive approach is fine. You may assume implicit stack space does not count as extra space for this problem. Okay, I mean contradictory. Recursion uses what fine. If it says can we use recursion, we'll use recursion. Let's try and see what we have to do. So node is a val, node is left, right, and next. Left and rights are populated, next is not. So in some way, if we can do a level order traversal, and it's given a perfect binary tree. I forget the exact definition, but where all the leaves are on the same level. That's the important bit. Right? All the leaves are on the same level. I feel like perfect binary tree is the one where each node has two non-null nodes. Right? Until the leaf. And then none of the leaves have any, basically, yeah. So all leaves are on the same level. Hmm. So if I do some sort of a level order traversal, then I would know that this is the only level, and then I'll put 2, and then I'll put 3. And sort of in right to left direction. So I save this, and next guys next is this, next guys next is this, something like that. So I'm thinking of level order traversal. Q1, take out 1, nothing else is there. Push 3 and 2, and then look at 3 and save it. Always save the previous guy. Yeah, so something like, yeah, I think just a regular level order traversal would suffice. Let's sort of do a walkthrough. So I do 1, put 1 into the queue, and then I pop 1, remove 1 from the queue, and the level is done. Right? Now, once I would have inserted its children into the queue, so 3, first I insert the right child, and then I insert the left child. I'll maintain something called as previous, and whenever a level is done, previous will be set to null. So here I pick 3 out, previous is null, initially, so 3's next is null, and previous is pointing to 3. I remove 2, Okay, and when I remove 3, also I'll add 7 and 6. But I'll know the indication of level, right? And then when I remove 2, I'll insert 5 and 4. And for 2, when I remove 2's previous was 3, so 2's right will be pointing to 3. And then because the level is done, I'll set previous to null. So for 7 it will be null, for 6 it will be 7. Yeah, I think it's pretty straightforward. Okay, if that's what you think, let's try and do it. So I define okay, it says node. What does it mean? So what if node is null? Whatever. So first let's do this. Return root. Yeah. And then what are the changes that we are making? So we take a queue. So it's called it's just a linked list. Okay. Okay, so we want to create a queue. So queue of node. Call it queue. Just a new linked list. And we insert queue dot add root, right? And then while queue is not empty, let's also save this node previous as null. Okay, so first you get so there is at a given point in time there is the number of levels. So int I want to keep track of the levels. So in this level these are the number of nodes. So you run through the list, and at the end of the level, when the level is done, you will set previous back to null, right? And yeah, so this is fine. For each node, what am I doing? For each node, I am first of all I'll pop something out of the queue. Peek and what do you call this? Poll, I think. So you remove the element, and its right will be set to previous, and not right, actually next. If node.right is not equal to null, then first you add right, and then you add left. Next is set, and then you also make previous equals to null. Okay, and this is good, and then you set previous as null here. If the loop is done, yeah, I think this is good. Let's run code. Compilation error. Yeah, this happens. Okay. Okay, so one example works. Let's check the other edge case example as well, where it says empty thing. Okay, and we got some. Oh, I missed the fact that you cannot use extra space. Fine, I'll fix the approach, but let's first see whether this works. Null point exception. Okay, it says node is null. Uh, so let's do this. If root is equal to null, return null. Yeah, okay. Submit. Fine, this works, but we cannot use this explicit extra space. We have been told not to use it, so we cannot use this queue. This one says recursive approach is fine. You may assume implicit stack does not count extra space. So because this is not allowed, we can stop and try to figure out a recursive approach. So can we do this level order traversal recursively? Hmm. Left, right, not value. I don't really want to see all this. Okay. What to do? If we don't take an extra space, then I take one element and then call. It is a perfect binary tree, which I mean every node has two children till the leaves. I think that is what I have to rely upon. So there is no thing about left being null and right not being null. That cannot happen, right? In which case, the root's left child's next will be root's right child, and then we go here. Its left child's right will be this, and its uh, left child's will be this. How do you connect these two? That's the only question. So root's left child's right would be root's right child's left child. Hmm, interesting. So could we do just like a obviously firstly if root is null, what's the problem here? We return null. Now what we do is root dot next is null. Connect is a good hint, I feel, the word connect. So connect, you have to connect root dot left and root dot right, and you return root. Okay, now So you do left dot next equals to right, obviously, and is the bit that you have to be interested in. So obviously you connect both of them separately. So you connect left dot left and left dot right. Similarly, connect left right dot left and right dot right. But you also have to connect left dot right to right dot left, and you break if f equals to null. Because it's a perfect tree, what would happen is both would be null. But let's just do this. Okay, this you don't have to do. Nulls are already set. So that is a breaking condition. And these are the three connects that we have to do. Left will connect to right, and then on further down the tree, obviously it's left, its right will automatically connect, but these two also have to be connected. And then these calls itself, so essentially with these, you handle these two, you handle these two, and you handle these two as well. Now let me see the next level, what will happen. Let's build another level and see what exactly happens there. So yeah, so we can imagine when we call connect 4.5, what will happen is it will do the connect on yeah. So you could actually just call connect on just root dot left. Sorry, you can just call connect on left. It will take care of its subtree, and you can call it on right, which will take care of its subtree, right? And the only thing that's left is this connecting these two, which you can do via you could just say left dot okay, let's understand again. So it was called on 1, so you can call on 2, call on 3, and connect 2 and 3. Yeah, I'm missing something again. And so when you call on 2, it will connect 4 and 5. When you call on 3, it will connect 6 and 7. Who will connect 5 and 6? That is also your duty only, right? Now, only thing that I'm not sure about is when I say connect on 4, 5, it when we say connect 2, it will connect 4 and 5 and call connect on 4 and 5, which will take care of their internal subtrees. Yeah, so this I do left dot uh, right dot next equals to right dot uh, left. I think that's the bit. What if left dot right is null? So you can do that. If left dot right is not equal to null, then you do this. Now let's try to run it again. So we're trying to connect left and right. Really, I wonder if these two are needed. Oh, these two are definitely needed. So let's build another example. 1, 2, 3. Okay, I mean, I'm lazy. Let's just walk through for this. So yeah, 1 calls in on 2 and 3 with 2 and 3. So you call on 2, call on 3. Yeah, that's the problem that it returns. Okay, so then I just call connect left dot left with left dot right and right dot left with right dot right, which will then internally call on this that guy and that. So 2 is calling on 4 and 5. 4 will do it on itself, 5 and itself, and link them. And between this is this. Uh, so 4 will connect its children. 4 will connect its children. 5 will connect its children, and who will connect those two? So 6, 7 connected. It's the same as here. Who is connecting these 5 and so we're called on 2 and 3. 2 connects with 3, which is here, right? 2 calls on its children. 3 calls on its children, and then we also connect their trees. Similarly, here also 4 will call on its children, 5 will call on its children, and we'll also connect their trees as well. Okay, so that works. But when you're on 6 and 7, 6 will call on its children, 7 will call on its children, it will connect 6 and 7. But what about pairs of the right child to 5 and left child to 6? You have to connect 5, 6. You can't just do this, you have to actually connect 5 and 6. There is some repetition happening that I agree. There's repetition happening that I agree. Because 2 is also calling connect 4, 5, so it will work on 5. Yeah, repetition I agree, but this also has to connect only. Left or right with. I mean, this works. First, let's confirm that this works, because I feel this definitely works. Yeah. Okay, submit. Let's see if it causes some kind of exception. No. Now I just feel that there is some repetition happening, which is this left dot right, left dot right, right dot left, right dot left. On these nodes, I'm calling connect twice. I mean, won't cause any harm, but I can also keep an extra space to not do that. So I guess I'm okay with this. All right then.